presentation will be about Java 8, given by Vlasta, and Scala 2.10. So enjoy it and we can start.
Okay, so the topic is Java 8 under the hood, and I will start with a question. How many of you are Java programmers or have some experience with Java? Okay, almost everyone. Java 8 will bring some major changes to the Java world, and the most interesting one, I think, is lambda expressions or closures. And this is why this topic is discussed on a meetup of Scala group, because that's something we are very familiar with in Scala. And as I said, it will be a major change or paradigm shift in Java. So lambda expressions. Is everyone familiar with the concept of functions or lambda expressions, functional programming? Yes. So I will not go into the very basics, what is a lambda expression, and we'll start by comparing the syntax, how those things are done in Scala versus the proposed syntax in Java 8. So let's start with a very basic example. And here we have a function literal or a lambda expression for a function that adds 1 to its parameter. As you can see, the differences between Scala and Java are minimal. It's only the arrow sign. The Java uses like the single dash, and Scala uses the equals sign. Also, in Scala there is a little shorthand syntax. You can write the same thing with underscore. It's the same. You define the same function as in the above example. There is no direct equivalent in Java 8. You always need the arrow here. Also, in Java 8, there are not just lambda expressions, but there are method references. If you have already defined method in some of your classes, it can be either an instance method or a static method, as here. ParseInt is a static method on integer class. You can use it at the same places where you could put lambda expressions. You can do basically the same thing in Scala. Of course, Scala does not have method references because it works with Java 6, or method references are something new in Java 8. So actually, those two things mean conceptually the same thing, but are implemented a little differently. This is like a shorthand for defining the function that calls the method. It's not a direct reference to the method. Also in Java 8, because a constructor is like a special kind of method, you can pass references to constructors. This defines a function that takes parameters of the constructor and returns an instance of the class. There is like no direct equivalent for this in Scala, at least that I know of. You can't create a function, like constructor is not a function. But for example, in the case of case classes, the companion object for case class is extends a function. So if you have, for example, case class, class, some, say. And the compiler will generate a companion object for the case class, which would look basically like this. And the companion object extends function. In this example, function 1. Or maybe it should be better written with the nicer syntax. It extends int to my class. So the my class companion object is a function. So you can use it basically the same way as conceptually the same way as the constructor reference in Java 8, but it's something very different. So as we've seen here, these expressions don't say very much about the type, or don't say what type is X, for example. And that's something common between that Scala and Java 8 have in common, and we'll look at what is the type of the lambda expression or the function. In Scala, there are 22 traits of function 1, function 2, function 3, and up to function 22 that define common supertypes for functions that take the number of parameters here. So every expression that you create with this syntax, we all know, we see here that this takes one parameter. So this will create an instance of function 1. And as I used there in the example with the singleton object, you can use the nicer syntax that you put one type, the arrow, and another type, and that's the same thing as, or is a shorthand for function 1 that has two type parameters, string and int. So this. Also, in Scala, functions are, as it is often called, first-class citizens in the language. There is a common supertype for the functions. You can do a lot of things with them. The function traits have methods. You can compose functions. You can Scala has currying, which is a concept in functional programming that basically says that a function that has n parameters can be expressed as a function that has n minus 1 parameters and returns, or function that has 1 parameter and returns a function that has n minus 1 parameters. And also there is, for example, a partial function that is a special kind of function. It extends function, but it does not need to be defined for every value for its type. So I can have a partial function of int, and it doesn't need to be defined for every integer. So there is some special support in Scala for functions. And in Java 8, the things are very different. there is no like common supertype for functions. The lambda expressions, as you've seen on the previous slide, do not all have to, the instance that gets created when the code is run is not a supertype of some common trait or interface, let's say function 1 like in Scala, but is an instance of something that's called the functional interface. And we will see an example on the next slide, but it's basically, functional interface is an interface that has one abstract method. So any interface that has one method can be used as a functional interface, and you can use in the API where you require an instance of that interface, you can use the lambda expression. And as we've seen here, that we don't say what the type of X is, the type, the actual type, is inferred by the compiler. So, for example, if you have, I will not draw on the board, but if you have a, in your API, you have a interface that has one method, and it takes like one int and returns, I don't know, string, then there you can use any lambda expression that like is compatible with the functional interface. And in Java 8, it's done like this because this system is applicable to all the interfaces defined in many Java libraries from 1996 up to today. So basically, like every interface you've ever seen that has only one method can be used as a functional interface. So it's done like this basically because of like backwards compatibility, and for the lambda expressions to be like usable on legacy code or legacy libraries. We'll look at an example of a functional interface. So it's an interface, it's called file filter, and it has one method that takes a Java.io file and returns a boolean. This interface is defined in the standard JDK in Java.io package, and it's not new in Java 8. I think it's from Java 1. And the only new thing here is this annotation functional interface, and this is not required to be there for it to be usable as a functional interface. But if you add a new method to this interface, it will not compile. The compiler will tell you that you cannot put this annotation on an interface that has two methods. So it's like the override annotation. It's like something. You're saying by putting this, it is meant to be used as a functional interface. Okay. Then we have some API. For example, on the Java.io file class, there is a method called listFiles. And it takes an instance of file filter and returns an array of files. Again, this method is old as Java 1, nothing new. But now you can use it like this. Instead of creating a subclass of file filter, probably typically in Java 7 and older Java versions, you would use an anonymous inner class at this point where you would define your instance of file filter, but now you can use lambda expression. So we have a Java.io file, we call the listFile method, and we pass a lambda expression here. So it's a function that takes one parameter f, and it calls get name ends with JPEG. So it returns a boolean, and the compiler will check that this lambda expression conforms with this interface that is required by the list files method. So it will check at this place that this lambda expression takes a file, so that you can call the get name on the f here. So at this place, f is a Java IO file, and it returns a boolean. So that is like the example of the target typing that I had on the previous slide. The actual type of the expression is like resolved or at the place of its use. For example, you cannot take just the expression and assign it to just any variable. You can only you could assign it to an instance of file filter, but not object, for example, because it wouldn't know what the type of f is. And like this is the basic example in Java, and let's look at how we could use this from Scala. So we have a functional interface. We have JDK8, we have Java 8 compiler or JVM, but we want to use this API from Scala. And as you see here, there's really nothing new from previous versions of Java, because looking from Scala, this is just an interface. Scala doesn't know anything about functional interfaces or lambda expressions in Java. So you can do the same thing you would do now. If you want to use functions instead of creating anonymous inner classes of file filter, you can define conversion, explicit or implicit, it doesn't really matter. And so this is a method that takes a Scala function from file to boolean and returns an instance of file filter. And it just hides the creation of the anonymous inner class in this method. So if you have this, you can call the list files method with a Scala function literal. And what goes behind the scenes is that the Scala compiler will see that here we need a file filter, and it will look for implicit conversions, and it will convert this function to a file filter method, and the method gets invoked with this instance of file filter. So it's really nothing has changed. So this presentation is called Java 8 Under the Hood. So let's go a little deeper. First, we look at how are lambda expressions or functions implemented in Scala. So as I said here, there are basic traits, those function 1, 2, or function 0, I guess, to function 22. And because Scala runs in JVM and the Scala classes are compiled to bytecode, the same as Java classes, and the current Scala 2.10 is compiled to Java 6 bytecode. I think you can change it to Java 7, but I don't think it changes anything but the magic file or the magic at the start of the class file. So there are interfaces or traits function 1 to function 22, and in the JVM up to Java 7 there is really nothing else you can do but to compile those lambda expressions to inner classes of the classes where you define them. So if you look at the classes produced by Java, the Scala compiler, if you use functional programming and function literals, you will see many classes with funny names like this. So it's basically says like, in my class, probably someone defined a function that's like here, and on fun1, and there are dollar signs and numbers and some, like the name doesn't really matter. It's just something the Scala compiler has to do to run this code in the current JVM. And as you can see, if you use functional programming heavily, you will get a lot of extra classes in your jar files will be very big. For example, if you use Specs 2 testing framework that is very like oriented towards functional programming, you will have a lot of extra bytecode. So, like from the point of the language, is like everything's okay and perfectly clean, but in the compiled versions of the classes, it's a little bit messy. There's like a lot of extra stuff that you don't normally see unless you have some problem or you will get a parent space leak or something like that. You need more memory, for example, for all those classes. And let's look how this is implemented in Java 8. And it's something very, very different. Java 8 does not define any special anonymous classes for the functional interfaces. It hides the implementation of the methods of those interfaces in synthetic methods in the class where you use it. So basically, where Scala will define a new like or inner class, Java 8 will generate just a method with the body of the function, and it will use a new instruction that was added in Java 7, that is a new byte, like JVM instruction, that is called invoke dynamic. We'll look at it a little closer. And basically, there is some clever class that is shipped with the JDK that will take the reference to this synthetic method. It will take the interface that it has to be compatible with the expression, and it will dynamically create an instance of the functional interface. So let's look at an example. I have to warn you, there will be like a bytecode on the slide. So here we have a like very trivial class with just one method that defines a simple lambda expression that adds 5 to its argument. And before I showed an example where you like put or you use the lambda expressions at the place where you call a method, you can also assign it to variables, but this has to be a functional interface. Actually, this one it's an interface that is defined in the standard JDK 8. So it's basically, as I said, Java 8 doesn't have like common supertypes for functions, but there are some like common interfaces are defined in the JDK, so you don't have to define new interface every time you want a function that takes an integer and returns another integer. And this code just prints the result of application of this function to 7, so it should print 12. The apply as int method is the only method defined in this interface, and this gets compiled to this bytecode. This here is an output of the Java key. I don't know what's the. It's a utility shipped with the JDK that basically gives you a look at the bytecode instruction in human readable format. Human readable. So here we have a definition of the lambda expression, and that gets compiled to these instructions. Here we see the invoke dynamic, and this just will store the result of the invoke dynamic in a local variable. And here another important thing here is the invocation of the method apply as int, and that's the standard instruction invoke interface that is in Java from the beginning. So the interesting thing here is this invoke dynamic instruction. And what is invoke dynamic? As I said, it was added in Java 7, and it was meant to be like better support for dynamic languages. Basically, it gives you an option to say that here what gets invoked is not like statically known from looking at the bytecode. This invoke dynamic instruction calls or delegates to a bootstrap method, and it passes some arguments that are known from the context to this bootstrap method, and this method will create something that is capable of invoking the parameters or invoking the method that is required. So let's look at this lambda meta factory class, and basically that is something new in Java 8, and it contains the bootstrap methods that are capable of converting lambda expression to these functional interfaces. Here we have a snippet from the actual source code of this class, and it has a lot of there is one, or there are two methods, but the important one is this one, and it takes a lot of parameters, but the important ones are the ones highlighted. It takes a method handle that is something in the java.invoke package. It's basically a description of a method signature. It tells like what are the types of parameters, how many parameters are there, what is the return type, and I think that's it. Maybe a name is there also. So it takes like references to two methods. One is called sen method, and as I've shown some previous slides, the functional interfaces are also known as single abstract method interfaces. So this is a reference to the the method definition in the interface, and the other, the impl method, is a reference to the generated synthetic method in some class that contains the implementation of the lambda expressions. And how it all works together, you will see some more bytecode. As you've seen there was a invoke dynamic instruction, and it takes a reference to basically what does this mean, like $, or #2. It is a reference in the bytecode. There is something that is called constant pool, that is a storage for
Dictionary.
or dictionary of like constants used in the class, and it's basically a reference here. And here we see that $2 is invoke dynamic like 0 and 24, and 0 is a reference here, and it tells it that 0 is a bootstrap method in Java invoke lambda metafactory. So the metafactory class and the metafactory method, and it returns something that is called call site. That's also something defined in java.lang.invoke, and it's basically something that can invoke method calls. And here we continue here. The bootstrap method gets these arguments, and those are basically the references to those two parameters. The SAM method, that's the method in the functional interface I used. You see here is the unary operator apply as int. It takes an int and returns an int. And the implementation method is a static method in this class, and it's the same class that you use your lambda expression in, or where you define it. So in this class there is a special method that is called lambda $10 that takes an integer and returns an integer. The signature is the same as here. So by if we look back here, I used the lambda expression was x plus 5, and after this journey through the bytecode, we can see that it gets the real implementation of this expression is in this compiler generated method. And if we look at the bytecode, again, it's just adding 5 to the parameter and returning it. It's a normal function. In Java source code, not in bytecode, it would look like this. So the whole functional stuff with the lambda expressions, it's actually on the bytecode level compiled into something that's not functional at all. It's just like helper static methods. But from the language perspective, it looks very similar to Scala, like normal functions, but it doesn't generate a lot of the extra bytecode that we've seen in Scala. So I think it's a much nicer implementation than what we have in Scala now. And I would ask the question, when will this be in Scala? Because I want everything to be efficient and don't want to generate extra classes every time I create a function, which is all the time if you program in Scala. So the basics that are required for this implementation is the invoke dynamic instruction, and that's something that was added in Java 7. So Scala will have to move away from Java 6. That is the current target platform for Scala. So, for example, I know that Android developers have the Dalvik or virtual machine that is basically Java 6. Android doesn't have the invoke dynamic instruction, so Scala wouldn't be usable on Android. And actually the plan here, or the plan for future releases for Scala is this. Scala 2.11 should have experimental Java 7 compiler backend, so it will be able to do something very similar to what Java 8 does with the invoke dynamic stuff, but it will be experimental. And they are saying that you should not publish classes generated by this experimental backend in like public repositories for your libraries and stuff. But so this will be experimental. People will have a chance like to express their opinions on that. And Scala 2.12 will target Java 8 directly. So in like 2 steps, we'll go from Java 6 to Java 8. 2.11 is should be released, I think, this year or maybe at the end of this year, and 2.12 is maybe 2014 or 15. So it's not imminent, but that is the plan. Okay, so we'll look at some more examples of actual use of lambda expressions in Java API, because so far we've seen only like the language syntax or features and how it gets compiled to bytecode, but Java 8 also comes with new changes in the standard Java library, and the big thing where the lambda expressions come into play is the new stream API. It's something that is very similar to Scala collections, but the creators of Java 8 have decided not to put like a lot of new methods like math, flat math, filter and stuff like that directly into Java collections. Instead, they created something that is called Stream API, and if you have, well, let's look at an example. So we have a list, java.util.list, with some strings, and here we see we invoke a method for each that is not, if you look at it in the Java list now, you can see this new method that takes a functional interface. I don't really remember how this interface is called, but I will have an example on a later slide. And here we pass a method reference to the println method on the print stream that will print the list to the standard output. So this here is an example where the method was directly added to the existing Java class. It's not actually the list, I think it's iterable. But here we see that to use some functional programming that is very similar to what we are used to in Scala, we have to go from Java util list to something to Java util stream or Java stream.stream. It's a new class, and the Java collections all have this new method that is called stream that will create a stream from the collection. And what is a stream? Like basically, stream is a functional view of the collection. It's backed by the data that's stored in the collection, but it's like a view that you can work with, similar to what you are used to working with collections in Scala. So I have the same thing done in Scala, and as you can look at it, it is a very, very similar. The methods have maybe different names. For example, here we see the map to int method, because the implementers of Java 8 want to be very efficient and avoid boxing of primitive types to integers. So the actual int type of this method is not just a stream. It is I think int stream that has specialized methods for ints. So instead of just a map method that would return a object or Java integer, so a boxed int, it has a special method just for ints, a map to int, that returns an int, not integer. And much like in Scala collections, there are methods basically like this changes the strings to ints, and then we filter out only the integers that are lesser than 250, and then we go back from the stream to something else. And that is something that is different than in Scala, because as you can see here, I think I have it highlighted, we are starting with a list and we are ending with an array. There are no methods like to list, to set, or to, I don't know. There is just a method to array, but you could create a Java util list by invoking some other functional method that would collect all the elements from the stream and create a list, but it would not be like the simple one-liner as it is here. And what is also interesting to point out that the streams are all lazy. Basically nothing gets done until you do something that needs to work with every element of the stream. So here I will create a stream called map2int that returns another stream. I will call filter, pass it a lambda expression, and also get a new instance of stream. Still nothing gets iterated over and filtered. But finally I will call this method toArray that returns a Java array, so it has to go through the whole stream and call the map function and the filter functions and go through that. So that is a little different than in Scala, because the normal Scala collections are by default not lazy. They are strict. Yes. In Scala, but I can do the same thing that I do with a stream. In Scala, you can create a lazy view of your collection by calling the view method, and you get basically the same thing as in terms of the laziness as here with streams in Java. If I didn't put the view method here, basically all these invocations would create new copies of or new instances of the sequence with the elements already processed. But by using the view and force here, I get basically the same result as in Java. But you can see that the types are different. Here in Java, we're starting with a list and then we end up with an array. Or we could also end up with a list if we did something a little more involved on this line here. But in Scala, we're starting a sequence of strings and we're ending with a sequence of ints. So basically 2.0, we are not going through some special middleman that is the stream. We have these methods are defined directly on the collections, on the collection classes. And I think that is a much nicer to work with. Also, Java 8 comes with parallel streams. And again, these are very similar to parallel collections in Scala, because if you have a stream, you can call the parallel method that will create a parallel implementation of that stream, and you can go back by invoking the sequential method. And if you've seen parallel collections in Scala, that is very, very similar. Even the names, parallel, sequential. And the implementation is similar also. It uses the fork join pool created by Doug Lee, that is in Java 7, and it's the same one that Scala uses for its implementation of parallel collections. And the basic idea is to make code that does things in parallel very similar to the code that works sequential. So both of these methods return still the stream. There is like no special interface, parallel stream and sequential stream. No, it just returns a stream that has the same methods like filter map, flat map, and so on, but just the implementation is done in parallel. So the only thing you need to do to turn your sequential code to parallel code is to invoke this this method, much similar to this what you do in Scala. So let's look at some more examples where lambda expressions are used in the Java API. As I said, there are like prepared standard functional interfaces, and those are defined in the Java util function package. So, for example, function is a functional interface that has one method, and the interface it's a generic interface. It has type parameters, and it's basically the same thing as function one in Scala. So it takes one input parameter and returns another. It returns one value that can be of a different type. You have a by function that is basically the same thing as a function 2 in Scala, but you don't have like try function or quad function or anything like that. And you don't really need to use these. Those are just prepared for you, so you don't have to define your own functional interfaces for like the common use cases. So, for example, the predicate is something that takes some one input value and it returns a boolean. Supplier is a function that does not take any parameters and it returns some value. And these are used in the streams API. So, for example, the filter method requires a predicate. And also one funny thing, if you know Scala has a trait that is called option, and it's a thing that is very common in functional programming, and in many other functional languages have something similar. Maybe, sometimes it's called maybe, and it's basically a container for a one value that can either be there or it's empty. So it's something you use when you want to avoid null. And now you have something very similar in Java, and it's actually used again in the stream API. And if I'm not mistaken, it's the only place it is used in the standard JDK. For example, the stream has a method like find first or find. Like if you want to find some elements that satisfy some predicate, and the find first method returns an option. It does not. It never returns null if the element is not present in the stream. And in Scala, the option has a method called get or else. Here in Java, it's called or else get. And here you would pass a lambda expression, that is this supplier here, that should produce some other value if this optional is empty. So those were lambda expressions, and as we've seen here, we've seen that there are some new methods added to standard interfaces in JDK. Here we see the for each method added to iterable, and well, that's basically it. This is a new class. And if you have some experience with Java, you know that it's not easy to add new methods to your interfaces, because if someone has implemented this interface in his project and you change the interface by adding a new method, the code will not be binary compatible. He will have to recompile the code and implement the new method. So, by necessity, the implementers of Java 8 had to add something that would allow them to add these new methods to standard classes that take these lambda or the functional interfaces as parameters. And the thing they have done is they created something that is called default methods. And here is the example from the iterable. The for each method. Java lang iterable is an interface that was added, I think, in Java 5 that is there to facilitate the for each statement in Java, and it has only one method, or it had only one method, iterator. It is not shown here. But now in Java 8, it has a second method that is called for each, and it takes a function that gets like invoked on every element of the iterable. And as you can see here, there is a new keyword in Java 8 default, and what you don't see here is that the method in the iterable interface has an implementation. So now, basically default methods are methods that are implemented in interfaces. And as I said, the basically only reason there are in Java 8 is for backwards compatibility. Without them, it wouldn't be possible to add lambda expression and the new stream API and parallel collections in any meaningful way. You would have to create some like special classes without modifying the standard collections, and that would not be. It would be very hard to use this API and to like interoperate with older libraries and stuff like that. So it was added out of necessity, but it's turns out it's useful in many other cases, and it is something quite similar to traits in Scala. So, does Java now have traits? Well, it depends how you look at what you want to do with them. Like the basic common idea is that you have interfaces that can have some method implemented, so then yes, Java has traits, but in Scala, traits can be used to much more than just implementing methods in interface. Like the language differences are basically that in Scala, traits can have vals or values or variables. Basically, they can have state. In Java, they cannot. They can have only methods. Of course, they are not. The type system in Java 8 stays basically the same. So you have no self types, and you can do like fancy stuff like the traditional cake pattern that uses self types. Also, you don't have linearization of classes in inheritance, because what happens if you in your class implement or extend two interfaces that have the same method? It's basically in Scala it gets resolved by you can have the classical problems that come with this. Maybe you know the diamond inheritance issue from C++ that has multiple inheritance, and the classic problem that you have one common superclass. Then you have two subclasses that both extend these superclass, and they implement the same method. And you have a bottom class here that extends both these classes. And what implementation you get, the one on the left or the one on the right. And in Scala it is resolved by basically ordering the interfaces that you mix in a linear sequence, and the implementation that is like the closest to your class wins. In Java 8 it's not like that. You can actually have the some issues. It's not exactly the diamond inheritance problem, but you have like resolved those conflicts manually. There is some new syntax added. I'm not sure if I want to go into detail, but no, I will not go into details. It's not that simple, and I think we should move on. But again, the Java traits issue. In Java, the default methods have a different purpose. The purpose in Java 8 for default methods is then you can add new methods to your interfaces without breaking everyone's code for those people who implemented that interface. And that's basically it. In Scala, traits are basically a building block for modularization. You can, as I said, the cake pattern is built on that, and you can like compose or your application by using traits and divide your classes to many smaller traits and stuff like that. And you can use self types to like bind it all together and get basically let the compiler do all the hard work to tell you that you have all the parts. So the some features are similar. Like the main feature is that you can have implementations in interfaces is the same as traits in Scala, but their purpose is a little different. But again, as with the implementation of the lambda expressions, I think there could be some potential benefits for Scala, and that's because in Scala the traits have some issues with binary compatibility, because now if you implement a method in a trait, because Scala gets compiled to Java 6 and there are no default methods, you have to basically copy the implementation of the methods from the trait to every class that extends this trait. And if you, for example, in some future versions of Scala that will target Java 8, you could implement traits differently, but only the traits that have only methods, because interfaces in Java cannot have variables. So it would be an optimization only for method-only traits, but I think that is a large enough subset that it could be beneficial. And as I said, you would no longer, if you implement traits using default methods in the bytecode, you would no longer need to copy the implementations into the classes that mix in that trait. So it could help with some binary compatibility problems that Scala currently has, but all you see here is just like my speculation or idea. It was not confirmed that the Scala 2.12 that will target Java 8 will use tricks like this, but I think it's a thing to consider, or at least an example that, or like the light at the end of the tunnel, that like the JVM, it's not static, it's evolving and new features are added to that other languages that run on JVM could benefit from. And finally, I have some minor other features that come with Java 8 that are not related to functional programming or traits. And it's also something that you can benefit from in other languages than Java, because they, for example, Java time is an addition to the standard Java library, and Java finally gets a reasonable representation of time that is immutable. Because it's level set that if you're programming in Scala and everything is immutable functional, and you have to use Java util date or Java util calendar. Of course, there is the Yoda time library, and this API is, I think, heavily inspired by Yoda time. But it's nice to have something like that directly in the standard library. Also, there are some changes that are not on the language level or the library level, but directly in the virtual machine. The first thing is that the parent-gen memory space, it is replaced with something different, and basically I think the practical use case or something you should remember about this is that probably many of you have seen the parent-gen space out of memory error. That the parent-gen space is something where like class definitions are stored, and in Scala, as we've seen here, because the implementation of the lambda expressions, you have a lot of classes. You can sometimes run out of this memory space, and because it is limited, when you start your JVM, you tell it by command line parameters how big this should be, and the meta space, the replacement for this parent space, is unlimited by default. So it will be a fun new source of memory leaks in future Java applications. It's very similar to implementations of this problem in other JVMs. I think that IBM, Java, and the JRocket use very similar to this. Also, and this is not in the current JVM or the JVM that will ship, but there is like a hope that when there are lambda expressions in Java 8, people will start to use them, and later, after they've deployed their applications in production, they will find out that JVM doesn't like functional programming very much. There are like issues, and again I will not go into details, but the JVM now it's like very advanced. It can do many optimizations and at runtime, and it turns out that some of these optimizations are not possible if you use the functional approach, or the approach where you have one interface and many implementations, like the function one or int operator. What was that? Int binary operator or something. The functional interfaces where you have many implementations implemented by the lambda expressions. It turns out the JVM cannot do so many. A lot of the optimizations do not apply for this kind of code. And there is some hope that the users of Java 8 will demand some more optimizations or improvements in future versions that would also be beneficial for other languages in the JVM. And the elephant in the room, as you probably know, Java 8 is not yet released, and recently it was delayed again. So it's not, there is, I don't think there is like one date that is guaranteed as the release date. It's like slowly slipping away, but the current plan is for release in 2014 in spring. So let's hope it will not be delayed again, and by this time next year we'll have it released. Here are some links on other resources where you can read something more about Java 8. Of course, I encourage you to download the snapshot or milestone builds from the project homepage. This is I think a great resource about lambda expressions and default methods and what they mean in Java 8. This is the Java doc, and if you wanna hear another talk about Java 8 that is more focused on Java and not on Scala, you can use this. There's a YouTube video, but it's only in Czech. And that's all. So it's time for questions if we have some. We do not. So let's look at something that is already released.
Okay, I have prepared a presentation about Scala 2.10, and I don't have to be quick because Vasta gave me only 20 minutes. So let's start. The main question of this presentation is, what does it bring? So the first thing is language modularization. There are some features in Scala that are considered to be dangerous or confusing or maybe experimental. In Scala 2.10 there are actually 2 experimental features. Or 1, I don't know, sorry. So the authors of Scala decided that these features should be explicitly enabled if you want to use them, so that like newbie Scala developers are not confused by them. So if you use these features and you don't explicitly enable them, a warning or error sometimes is emitted from the compiler. Example of such a feature is, for example, implicit conversions or macros, which are new in Scala 2.10. So here's another example, postfix operators. You can see a postfix operator here. If you have an object and you call a method on it and you don't use a dot between it, this is considered to be confusing or dangerous in some ways because the compiler can have problems with semicolon inference. So in Scala 2.10, a warning is emitted from the compiler, and you have to import a postfix ops implicit value from the language object so that the warning is like disabled. There is another option. There is a compiler option you can give to the Scala command, and it will make the postfix operators enabled for the whole source code you are compiling. In this case, they are enabled only in the scope you import this feature. Okay, what else does it bring? String interpolation. Do you remember this code where you had to concatenate strings by using plus sign? I say no more. Scala 2.10 brings you so-called string interpolation. You have three standard interpolators, S, F, and rho. And you have an escape character, $, which you can use inside the string to designate some expression which can be in curly braces, and it is interpreted as regular Scala code. If you have, for example, only a variable, you don't have to use the curly braces here. You can just put the $sign and the name of the variable inside the string. And the value of the variable is put inside the string. But Scala is a general language, and authors of Scala don't like to make some special compiler or language features, so they make everything very general. That's why string interpolation is also general. If you want to make your own interpolator, you can create an extension method of string context. For example, in my case, I called it ref. And if you do this, you can use your own interpolator like this. In this case, this interpolator would reverse the string, and the implementation is not really important. What you have to do is create some class that contains this method, and you have to make an implicit conversion from your class to string context, and all this will allow you to call your interpolator like this. This feature is much more powerful, but I will not go into details here. Okay, what else does it bring? Value classes. In Scala 2.9, you could not extend from any val. The only classes that extend from any val in Scala are wrapper types for primitives from Java. In Scala 2.10, you can do so because it brings you performance with type safety. Simply said. For example, you have some types such as kilogram, and you don't want to interpret it as double because you want your code to be type safe. So you create a wrapper class for double, and you put your methods in there, and so everything is type safe. But you lose performance because all your primitives at runtime have to be boxed inside objects. In Scala 2.10, value classes allow you to get rid of this. On the other hand, they have some limitations. Your value class must have only one constructor parameter, and it can only contain methods. It can't have any other fields or values or things like that. As I said, imagine you want to create a wrapper class, in this case called myInt, and it wraps some underlying integer, and it extends from any val. And you do this because you want to have the method called +1 in there, which adds 1 to the int you wrap. You can use it like this, simple. But at runtime, this is compiled into a call of static method that gets the value of the class from here, and it adds 1 to it. So at runtime, it's only primitives. There are no objects involved. What else? Cute puppy. Actually, no. It only brings us implicit classes. Implicit classes are very useful because if you code in Scala, you know that you write a lot of implicit conversions to convert from some object to another type of object. And it's a lot of boilerplate code that can be generated for you, and implicit classes do exactly that. The limitation is that the class must have only one parameter list with one parameter. Or actually, its first parameter list must have only one parameter. There can be another parameter list, but let's not go into that. And the implicit conversion the implicit conversion from the parameter of your constructor to your class is automatically generated for you. And this is often used with your value classes. So if you create a value class and you also mark it as implicit, you get the type safety, you get the performance, and you also don't have to write the implicit conversion. So you get everything. Another limitation is that you must define this implicit class inside some other object, class, or trait. It can be a top level thing. Here's the example. Again, I have my int class and I mark it implicit. That's right here. And as you can see, there is no implicit conversion, and you don't have to write it. You can just write your integer here and call +1 method on it, and it will be implicitly converted to my int, and everything will be fine. And by using anyval here, it will also be at runtime represented by primitive types of Java. What else? Dynamic trait. Scala is statically typed, and it does not allow you to call a method on an object if the type of the object doesn't have the method. And trait dynamic allows you to do so, but it's not the same thing as in dynamic languages. It's at the end, it's statically checked, but it looks like dynamic language. It allows you to call a not existing method on a static type. I will give you an example and you will know what I mean. It's very useful when you want to create a domain-specific language or you want to integrate your code with some dynamic language. There is a marker trait called dynamic that your class has to extend from if you want to use this feature. You also have to enable it by importing the feature from the language object, as I've shown on the first slide. And the rules for type dynamic are following. If you call a method on some type and the compiler will find out that there is no such method, it will try to look, and there is no implicit conversion that would allow you to type check that, the compiler will look if the type extends from dynamic, and if it does, it will try to look for one of these or all of these methods. And if it finds one of these that will allow him to type check the whole thing, it will use it. Example, imagine you have a case class record that represents one row in your database, and it consists of ID and name. It's not very important. Then you have a object record, companion object, that extends from dynamic, and it implements the apply dynamic method that has this signature. This will allow you to do something like active record from Ruby on Rails, I think, if I'm not mistaken. It allows you to call find by ID on record, and it should return you the record from database that has the ID 1. You could also call find by name here. And what will happen, the compiler will rewrite this to record.applyDynamic. It will give the method the name of the method you called, and it will give it the parameter. So this method in its implementation can look what you wanted, it will get the parameters, and it will do what you wanted. Question? Yeah? No? Okay. So, and as I said, this is apply dynamic if you just call a method. There are also select dynamic if you want to select a field from a class, or apply dynamic named with named parameters, or update dynamic if you use something like object.field equals something. So then update dynamic would be called. I think this is very powerful, and even though it looks dynamic, it's statically checked at the end, so it's absolutely fine to use it. Macros. Macros are a very new thing in Scala 2.10, and they are actually still considered to be experimental, so you have to import them or enable them if you want to use them. If you know Lisp, Lisp has macros very similar to Scala's macros. Macros are means of compile time meta programming. They are actually functions that are called by the compiler at compile time, and they are given a context and abstract syntax tree of its arguments. And they do something, they generate another abstract syntax tree, which is inlined at the call side. And it's also type checked, so everything is statically checked. Here's an example. Usually we want to have some debug messages in our code. The problem is that if you have some expensive computation that's in the debug message, this way it would be computed every time the code would go over this statement, even though the debug mode would be disabled, for example. So what you should do is you should put an if around it and check if the debug mode is enabled. Then it would be fine. The problem is that this code is ugly. So you don't want to write it, right? What you can do in Scala 2.10, you can write a macro called debug, and this macro will get an abstract syntax tree of this expression, and it can generate this code, this whole code for you. So in the end, it will be the same thing as if you would wrote it, but the code looks simpler, like this. And there are much more options, or many more options you could use macros for. For example, they are used in the Slick library for database access. It's the newest library from TypeSafe, and in the future I think they will offer us much more. And I was very quick actually. And the last feature, in my opinion the best, is the triple question mark. If you have some complex method in your code and you still don't know how to implement it, in Scala 2.10 you can use triple question mark, which is implemented like this in your standard library. And the code will compile, you can go on and do other stuff, do other methods, and then go back and implement it when you're ready and when you know how to do that. And I think it's very useful. And I hope I will be able to use Scala 2.10 very soon. Okay, that's it. Do you have any questions?
For the macros, how can you distinguish between method or macro and the call side?
Yeah. When you use a macro, you cannot distinguish it. But when in the implementation, it usually looks like there's a special keyword called macro. So it would be something like, let's say this. You have object logger, and it implements method debug. It gets some arguments and it returns something. Let's not go over that. But in the implementation, there is a keyword macro used, and you give it the name of the implementation. Usually, it's like something like debug impl, like debug implementation. And then you have to have somewhere the debug implementation method that does the whole thing. Any other questions? Okay, so you get the treats if you go with us to a pub if you want to. So thank you.